All right, so this is a project that I've been working on for the past couple of weeks. This is the 16-bit CPU from the Nand2Tetris program, completely built on breadboards. So I'll just walk through kind of what I did, what I'm doing, and because this isn't a finished project yet. So we can see these boards right over here. This is the arithmetic logic unit. So it basically performs the mathematical and bitwise operations, and the output is output onto these LEDs right here. Next up, we have the A register. This thing with the white wires, that's the A register. And it's used for the immediate storage of a value from the CPU input. You can see right here, this is a D register, and this is used for storing values from the output of the arithmetic logic unit. So that's why there's this big long black wire here. We have the program counter right here. And this ROM chip here, well actually this one and this one have yet to be implemented, but this will be the memory for the computer. Now, you'll notice here that, so right here, this is where you can send instructions to this whole CPU. And normally you'd have a ROM chip and have it preloaded like an EEPROM, electronically erasable memory, solid state memory. But unfortunately, there seems to be a chip shortage of that these days. Either chip shortage or they're just grossly overpriced, like $200 for a part that's normally $4. So I've just been using this TNC 4.1 to kind of emulate a ROM chip. And you can see here, it's just basically sending machine code here, cycling the clock, and we can see the output on the LEDs. So this is an A register, that's a D, and this is ALU. So if I turn the light off, it might be a little bit easier to see, but you can see this white LED, that's the clock pulse. Every clock pulse, the program counter increments, and right now I'm having it at 1 second intervals. This is A register. This is it's being continually loaded with values. This is a program output, the ALU output. It's pretty busy right now, just computing all the various functions that this machine code is writing. And we can see there's a D register, and on an as-needed basis, it's updated to the correct one, to the correct value from this output. So this is kind of what I've been working on for a bit. Haven't been flying FPV that much, but this is certainly a very interesting project, and some of the next steps would be to hopefully add some sort of display or screen, and then also add a user input to make it a fully functioning rudimentary computer.